Let's take a look at equations of kinematics for constant acceleration. We already took a look at this equation here, which gives us the average velocity in terms of the displacement and the time interval. I'm going to call that equation 1. If we have a constant acceleration, this equation is also valid for finding average velocity. The original velocity, which is an instantaneous velocity, plus the final velocity, which is an instantaneous velocity, divided by 2. I'm going to call that equation 2. And then we have the definition of acceleration, which states that the acceleration, that's an instantaneous acceleration or constant acceleration, is equal to the final velocity minus the original velocity divided by the time interval. And that's equation number 3. Suppose we wanted an equation for the displacement of a moving body in terms of its original velocity, final velocity, and time. So if you look at these 3 equations here, there's no equation that involves original velocity, final velocity, and time. So what we're going to have to do is combine equation 1 and 2. So I'm going to set these 2 equations equal to each other. This equation gives us the displacement in terms of the original velocity, final velocity, and time. And that I'm calling equation 4. Suppose we want to find the displacement of a moving body in terms of its original velocity, time, and acceleration. If you look at these 4 equations, not one of them will do that for us. So what we're going to have to do is combine these equations. And the equations that we're going to combine are number 4, the one I just derived, and number 3. I'm going to solve equation 3 for final velocity and then substitute it into equation 4. So let's solve equation 3 for final velocity. Here it is. Final velocity is equal to the original velocity plus the acceleration times the time. That's equation 5. Now I'm going to take equation 5 and substitute it into 4. And there we have it. The displacement is equal to the original velocity times the time plus 1/2 the acceleration times the time squared. And that I'm calling equation 6. Suppose I want to find the final velocity of a moving body in terms of its original velocity, acceleration, and displacement. Okay, you will notice by looking at equation 1, 2, 3, 4, 5, which is basically the same thing as 3, and 6, we can't do that unless we combine 2 or more equations. So what I'm going to do is I'm going to solve equation 3 for time, and then I'm going to substitute that into equation 4. And then we'll have the ability to solve that new equation for VF in terms of only VO, acceleration, and displacement. So let me solve equation 3 first for time. And now I can solve for VF squared. And this is equation 7. This allows me to find the final velocity of a body in terms of its original velocity, acceleration, and displacement. These 7 equations are very useful kinematics equations when you have constant acceleration.